Welcome back. So I know some of the stuff in the previous lecture was really rushed. Normally that would take me a whole hour to explain, but I had to stuff it in 15 minutes, so it was very rapid. So these solutions might be uploaded, but they'll probably be uploaded onto the forums instead. So if you want to go there, just go into HSC Extension 2 forums, look for the compilation of hard problems thread, and you'll probably find the solution there in a couple of days. Anyway, let's move on. So this was a really horrible 2015 question paper. It wasn't really the worst possible thing, but it was definitely very daunting to look at. Part 3 was the big kill, and we'll see why soon. I'm going to jump into it straight away again. So, part 1. Let n be an integer, and then want you to consider cos alpha plus I sine alpha to the power of 2n. And what you're trying to prove is that cos 2n alpha is equal to this nasty thing going on here. And whether or not you recognize what to do here depends on how much exposure you've seen. This is basically the overclocked, the OP version of basically your standard de Moivre theorem and binomial theorem trick. And the idea is that you start with something, you use de Moivre theorem straight away to get to that basically, and then you use the binomial theorem to expand the whole thing out. Now, because we're talking about cos, it should be somewhat clear that we're considering only the real part. We don't really care about the imaginary part. So I basically highlighted in magenta all of the terms that basically are real. The idea is that if you raise I to an odd power, you're going to get something that's imaginary. And if you raise I to an even power, you get something that is real. And so you get that. And then once you equate the real parts, you get all of this. And well, the idea is that if you have I squared, or I to the 6, or I to the 10 or something, that will ultimately become -1 using this chart. Whereas if you have I to the 0, I to the 4, up or so on, you will ultimately end up with a plus instead. And the idea is that basically that's how we get rid of all of the i's and replace it with -1 to the n-1 and blah blah. Yes, I do say blah a lot, and that is literally what 4-unit math is. Just in case you didn't know, yeah? And so the next part, we're given a polynomial. Apparently it's a polynomial, we're trying to prove that. But we're basically saying t2nx is equal to this expression, and depending on how well you can see things, you should realize straight away, all I had to do was just let alpha equal to cos inverse x to get the left-hand side to fall out straight away. So, surprise, that's what you do. And the idea is that you can use your Pythagorean identity to break apart your cos and the sine from each other. And once you do all of that, you resolve for that straight away. So this part is actually the easiest computationally wise, but it might be really hard to see. And the idea is that if you really want to be able to see it clearly, just think back to what you did during 3-unit binomial theorem. Substitutions were very common then, and substitutions can also be a tool for you to use now. Alright, part 3. This was a big bad. So we know that t2nx was equal to the cos and the binomial expansion. What we want to do now is to consider the roots of t2nx, and then want you to basically find the value of that. And the instant you see that, you should be thinking, oh, okay, it's probably product of roots. But to actually find the product of roots, now that's going to be much harder. So we'll start by setting t2nx equals 0 to actually get the roots, yeah? Makes sense? So if the cos of blah blah is equal to 0, I can use a general solution for cos. And what I'm going to do is I am going to rewrite the general solution as something else. You might not be able to see how I did this, because this is something that's not obvious. The easiest way to convince yourself that they're the same thing is to just draw the graph of cos and then work it out from there. This is basically an alternate expression to the general solution of cos x equals 0, and it only works under the condition that your so-called related angle is equal to pi on 2. And then what you do, you rearrange it, and you get that. Now, if you remember with your old binomial theorem and complex numbers questions, you will need however many roots as is your degree of the polynomial. Here the degree is 2n, so we're going to need 2n distinct values of k to get our distinct roots. So I'm just going to take in the consecutive numbers. That's our normal thing to do here. And eventually we get back to that. And surprise, that is exactly what we had here. So now, product of roots guaranteed to work. But the product of roots of that is not easy. And the idea is that we need to actually consider the product of roots of a general polynomial, and the product of roots has a nice formula for it, and that it's equal to -1 raised to the degree of the polynomial, which is 2n here. The constant term, which if you do all your expanding, you'll see it's going to be just -1 to the n. And the leading coefficient, so the coefficient on x to the 2n, and that's what's really, really screwed up. To get the coefficient of x to the 2n, we need to consider every single bracket. Here the coefficient is 1. Here the coefficient will be -2n choose 2 times -1, which gives you 1. Here the coefficient will be 2n choose 4 times, if you expand that out, you're basically going to get 1 times x to the 4 here. It's really hard to explain over a video, but the idea is that we actually want to find the coefficient of x to the 2n in all of these terms. You might want to ask me online for help with that, but the idea is ultimately you'll get to this nasty expression here, and the question is, well, how am I going to simplify that? And the reason why this is so scary is that this is normally a 3-unit question where you would have lots of help for, but here you don't. I'm just going to throw you the method straight away. The idea is that if your bottom index is always going up by 2s, you need to put x equals 1 and x equals -1 into your binomial expression here, and then you have to add them together to get what it is you actually want. Ultimately, you find your end result will be that. Last part, however, is a nice and easy break. I'm just going to talk about it very briefly. Last part, all you really have to do is realize that if you sub 1 on root 2 in, basically all of these will become 1/2 to the power of something and 1/2 to the power of something. I make a mention to it here. And on the left hand side is also really nice because you get your pi on 2 to fall out really quickly. And again, it's really just a substituting skill. You could also use your result from part I instead if you don't want to do it this way. Not really too much for me to explain here, apart from the fact that you just have to use your intuition every now and then. The only thing that really was counterintuitive was part 3 of that question, honestly. And the last question for the content block is basically just talking to you a bit about how they can mix up topics together. Here they mix up 2 of the more annoying topics, conics and mechanics. And I definitely do advise taking the time out to read this in your own time to be able to digest fully what's going on in the diagram. You see a lot of information get given, and you might not necessarily know when to use what. But for our cases, we'll just jump straight into it. So for part I asks a theoretical question, which is a reminder to you guys to basically know the theory behind your stuff. Know your theorems, know your formulas, and know your methods and whatnot. What information indicates that P lies on an ellipse with foci S and S dash with eccentricity E? As it so happens, how this works is just the fact that we know the length of the string, which is this, is going to be 2a. So really all we're saying is that PS plus PS dash is 2a, and hopefully you recognize that this is the 2 foci definition of the ellipse, which is also in my notes, and pretty much that is all they wanted you to say for that 1 mark. You would think that is harder, but it actually is not. And now they say, well, okay, use the focus directrix definition of the ellipse. So whilst you don't really have to do this, what I've done is basically just drawn the graph out for you to make it a bit more clearer. And we're saying, well, okay, let M be the point of the directrix, blah, 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 blah. And the focus directrix definition is really saying that PS divided by PM is equal to E. So PS is equal to EPM, and that's given down at the bottom. And from here, it's literally the same old process that you're used to. It's all the same thing that I've hopefully mentioned in my notes as well. You just plug it in, and your formula will just come out straight away, nice and easily, because you have a horizontal distance, and not a diagonal one. Alright, for part 3, I want to talk about a word that some of you guys might be really, really scared to use, because you don't know when to use it, and that is the word similarly. Similarly is basically the shortcut to skipping steps. It's basically what you use when you decide that how you want to get to a result that you're going to write down, in this case, a formula for PS dash. You decide that this result follows the exact same line of working out as you've done in the previous parts, just maybe with a plus or minus change or a number change. And if you can see the answer straight away and promise to yourself that you're definitely right, then you can use the word similarly. Otherwise, don't use it and be safe. Here I'll say that similarly, PS dash is equal to blah blah blah. And well, we're going to use trigonometry here, so I've added more information to our diagram. I've added beta in. Carefully note that we've kind of had to rotate our ellipse in a way to get it to look like that. But anyway, sine beta is going to equal to QS dash over PS dash. Well, we know what PS dash is, but what is QS dash? Well, we actually know that Q is the point 8 cos theta 0. If you scroll back up to the question, you'll see that. And this distance here must be AE for hopefully obvious reasons. And from here, you basically just plug it in, and it's just ordinary trigonometry, and somehow your result falls out straight away. So at this point, you might be realizing that some of it's actually not hard. If you just keep calm and use what you know, some questions are much easier than what you'd expect it to be. And when that's the case, basically, take a deep breath, you can do it. So, part 4, by considering the forces now, so hopefully you're used to doing your forces resolution in mechanics at this point. The idea is that in this scenario, if you do the whole vertical solution, you'll get this resolution going on. And you'll notice that I chucked in an alpha that wasn't originally in the question, and I chucked in the alpha because I thought, well, okay, beta's here, and that's related to this tension. Well, what about this tension here? I got nothing, so I'm just going to let alpha be equal to angle QPS, this angle over here. And then, similarly, I can use trigonometry again to get a formula for sine alpha, and then at this point, again, all I need to do is just plug into the formula. I'll get mg is equal to t times a bunch of random, and hopefully at this point you're thinking, oh, that's really promising, because when you combine the fractions, difference of two squares will get you to the denominator that you want to get to, so you're just counting on the fact that the numerator works out in your favor, and I promise you, if you do all the computations, you'll find that the numerator does work in your favor after all. And that's that one done. And part 5 is probably the really, really hard one of this question, and I've removed some information of the ellipse I think is kind of useless now. They want you to resolve the stuff in the horizontal direction, and, well, excuse me, in the horizontal direction, well, what's going on here is that if you do the horizontal direction, you're going to get cos everywhere, and, well, if you do cos of beta, you'll see the cos of beta is going to be equal to r over ps dash. We do know what ps dash is from over here, but we don't really know what r is. And if you look at what we're trying to prove, r does not actually appear at all. So that means somehow we must not use r. The trick here, however, is to realize the one thing. R is basically just the height of QP, but the height of QP is nothing more than just the y coordinates of P, and that is actually b sine theta right here. So effectively, what we're trying to get at is that r is actually equal to b sine theta. But I introduced b out of nowhere. If you go back up to the original question, you'll see that b didn't appear at all. B was just something that I left there for my convenience just to view the ellipse. So somehow I gotta now get rid of the b as well. And, well, the only way I can possibly get rid of the b is just to use my formula for the eccentricity. And therefore I get a formula for r. Now we become a bit less scared to do our force resolution. We plug out everything in. mr omega squared, the circular motion, is going to be the sum of these two forces. Do our trigonometry, we get that. We can basically put the r out in front and sub the formula in. And then again, after a lot of really, really messy algebra, you will ultimately get back to where you want to get. Somehow. And part 6, again, a no-brainer. Every 4-unit student, I hope, should be well familiar with the fact that sine on cos is equal to tan, and the fact that you have something with sine here and something with cos here makes the idea of using sine on cos equals tan pretty darn obvious, if you ask me. And when you see a question like this, just use what you know. Voila, free mark. Alright, and that concludes all of the content stuff, so I'll see you in the next video with some more lecture slides.